Thanks for inviting me. And first of all, I appreciate that you are still around. I know how it is. Last day of the conference, you want to go home, catch flights. Yeah. So thanks for that. So we've been talking a lot about software-defined networking at this conference. We've been talking about all types of applications and use cases from multi-layer, multi-domain, service provisioning, to multi-layer network optimization. And I think it's good to see that I think our industry is using the SDN architecture as a common architecture for all these applications. I mean, there's still a lot of work to do regarding specifically the interfaces and the APIs. We heard that in all these discussions, yeah, but at least it's a common architecture, which is good. And the other thing, what I really like these days is that we are seeing the first real commercial deployments of SDN architectures. And interestingly, this is not about all these fancy things we used to talk about, like bandwidth and demand. It's relatively straightforward for multi-vendor network management. So this is the area where we are seeing the first commercial deployments, and that should also be somehow the agenda and flow of my presentation, and my thinking about how things will evolve from today's multi-vendor network management, basically for configuration management and monitoring application, to multi-layer network optimization, which will take place at a little bit later, and we'll also see why, to full network optimization. And right now, we are seeing that multi-vendor application in all network areas. We are involved in a couple of projects where we are integrating carrier Ethernet devices into end-to-end orchestration systems for that purpose. But I've brought an example from a different area to this conference, from the optical area. And in optical networks, this multi-vendor topic is basically coming up with the whole topic of disaggregation. And this was also one of the topics at this conference. And I think we are already using a disaggregated approach in our networks, but currently I typically would call that from a vertical perspective. So we would typically have different vendors for the optical layer and a different vendor for the router layer. Yeah? So there is already disaggregation from this perspective, but at least from an optical layer, typically we would still use end-to-end systems from a single vendor. Of course, having several vendors in the network. Yeah? So from this perspective, you would have some multi-vendor capability. But of course, this approach has also some kind of advantages, and that's the reason why the people are using it. The entire system integration is in the hand of this single vendor. The network planning is a task the vendor is doing. Typically, we are also differentiating to competition through performance optimization, yeah, so that you would get the lowest cost per bit. Yeah. This is all, let's say, something we can do with that approach. Yeah. But on the other hand, of course, we understand that people are looking for more flexibility. This has been discussed at length at this conference through disaggregation. And so the model in the middle, yeah, would be, let's say, an idea, yeah, where all the network elements in the optical layer would come from different vendors, yeah. Basically for introducing flexibility and also giving the people the possibility to introduce new technology faster. I think one of the speakers yesterday said that with the current model, if they want to introduce a new technology, they would have to exchange the entire network, which is true, yeah. With the middle model, if you will, yeah. This is something they can approach much faster. However, we will move a lot of tasks we vendors are doing right now, and I have to say very often we are doing that free of charge. We are moving that to the operator, and that was, for instance, also one of the topics the previous speaker was talking about, that much more skills and things have to be done by the operator. So for instance, integrating all these network elements, yeah, something the vendor is doing right now is now something the operator has to do, or a system integrator. And then, of course, you would need all these standardized interfaces to achieve this integration from a control perspective. The other thing is network planning. Yeah, we are talking about analog optical networks with a lot of parameters, dispersion, polarization, and so on. Yeah, maybe a lot of stuff even some people don't know. This is then also something a single vendor cannot do anymore, yeah, because if I'm delivering the transponder and Huawei is the ROADM and the next node is coming from Siena, yeah, then no single vendor can do this end-to-end network planning and link planning. So this is then something, again, which will be offloaded. And that's why, and I will give an example how we as an industry are addressing that challenge. That's why I think the model at the bottom is, let's say, the common sense right now. So most of the people are looking at that one, at least if it comes to the next phase of deployments, where the analog optical layer would still come from one vendor. And then again, you would have some vendor domains so that this vendor can take care about the integration, about the network planning, about optimizing the performance and so on and so forth. And more importantly, having one domain controller with one API, yeah, so much simpler to integrate, but still having the flexibility that the terminals would come from third parties so that people can introduce new technology faster, 400 gig as an example, or introduce packet optical aggregation capabilities like the TIP project is proposing, or even that the interfaces are moving into routers, so giving the people the flexibility. And one example for this lower approach, this is what we have or actually are still testing in the network of Telia, and we have also demonstrated it here at the conference. So if somebody had the chance, we had a remote connectivity into the network. So this is such an example of a disaggregated optical network. We had two optical layer islands, if you will, delivered by Coriant and ADVA. Disaggregated transponders, so exactly the concept shown before. And what we have done here is basically that the domain controllers would expose the optical topology to a multi-domain controller. That multi-domain controller would then calculate the end-to-end performance based on OSNR, yeah, and verify which links would work and which links would not work, and would then request certain links to the domain controllers, and then the actual configuration would then be done by the domain controller. So again, the domain controller would hide this optical analog complexity to the multi-domain controller. This is the statement or one of the requirements the colleague of KPN told us this morning, that this abstraction would be very important. Yeah, so this was a good example for that one. And then I mentioned the telecom infrastructure project already. This community is also looking at this disaggregation challenge, basically looking at all the topics, yeah, I've been talking about, so the APIs, the open line system, so this is the optical layer, the disaggregated transponders, and most importantly, maybe from my perspective, the link planning. Yeah, like I said, the link planning is something vendors are typically doing on their own, and like I said, very often free of charge right now. If you go to a full disaggregation, yeah, then you need to have some third-party tools doing that job. And Telecom Infrastructure Project is working on a quite nice model using some assumptions for noise and interference. And actually, Microsoft has reported quite interesting results at the ECOC 2 weeks ago in Rome at the Market Focus. Mark Feiler was giving that presentation. They have set up a test scenario in their lab, a 2,000-kilometer link with various vendors, and they tested real performance, various predicted performance by the tool, and they were assuming an accuracy of plus minus 1 dB, and the actual accuracy was lower, yeah, 0.75 dB, which is showing that this is possible and which is showing that the industry is going into the right direction here. So this is more or less what is happening now, multi-vendor configuration management and monitoring. Now the next step, as I said, will be the multi-layer network optimization. I think this is something we've been studying for years. We've done thousands, let's say thousands worldwide, lab trials, field trials, POCs. My personal experience is why this has not really been implemented in commercial networks on a larger scale is that if you talk with the procurement teams of our customers, yeah, then they would say, look, understood, multi-layer network optimization is important, but this is what we are doing already today, but manually, and we have the people and we have to pay the people. So why should I pay another money for SDN architecture, yeah, if I've got it already today with the people I'm having in my company, yeah. So this is kind of a feedback we are getting sometimes. You see there always some flavors, and this is one of the reasons why I'm saying this will only come tomorrow. But if somebody would like then to ask when tomorrow will be, I already say right now I don't know, yeah, at this point in time. One example is what Oscar showed us already earlier. This is the ORF interop event. He was explaining in detail, so I won't repeat it. This was a classical multi-layer optimization topic. Just to maybe expand on one topic, I think Oscar was not explaining in detail, is this restoration topic, for instance, so that just that you know why this is relevant. Restoration, for instance, you can do in different flavors. You can do a pure restoration in the optical layer and then just report the result to the multi-domain controller, yeah, and then the multi-domain controller could then reroute accordingly. Or the restoration could be done by the end-to-end controller, specifically in such a multi-vendor environment, yeah, because only he would know what would be the optimum path through these various network islands, and then request the links accordingly. Yeah? So there are different use cases and different options, yeah, and different ways how to optimize the network. That is one of the topics here, but I think also Oscar told us in the morning that there's still some work to do, yeah, regarding the information model, yeah, and also aligning with other bodies, and that's why I think there's another reason, of course, yeah, more technical reason why this will still take some time for implementation. Another example is network slicing. I think this was also mentioned in the KPN presentation this morning. This is a 5G example, something we have done with BT and shown at the Mobile World Congress this year. So anybody who's been in Barcelona maybe have seen that already. This is a flexible infrastructure, which is basically connecting various types of mobile architectures. So classical small cell base stations being backhauled to the core, front-haul technologies using remote radio heads being connected to baseband units in data centers, using network function virtualization, yeah, so virtual EPC, virtual BBU software from different vendors in order to scale and align the functions accordingly to the requested services. And that on a flexible infrastructure. And slicing, of course, would mean that every operator, every mobile operator would get his own network slice, yeah, obviously. Everything controlled by an SDN controller, you see on the top there, delivered by Lumina in that case. Yeah? And from a slicing perspective, obviously, this can then be on all the transport layers. It can be in the optical layer, so that would be different wavelengths. Wavelength number 1 for Vodafone and wavelength number 2 for T-Mobile. It could be on the OTN layer. It could be in the Ethernet or sub-Ethernet, if you will, layer with VLANs. Yeah, so there are all these. It could be labeled switch paths. So there are different options, and everything, of course, needs to be controlled, and that's why then the SDN control is making sense. So this would be a multi-layer network optimization problem. And finally, things we are studying now in detail in the industry, and which will certainly come at some point in time, would be then the more complete automated network operation. I think the basic idea is we've got a lot of data in our networks. Yeah? So every network element is measuring and storing a lot of data in the access, mobile, residential, in the core, everywhere. We are not using this data. Yeah? So if we would use all the data which is available right now, even at this point in time, we could do something with this data. And that's basically the idea of network automation. So again, following these steps, yeah, and I think I talked about that earlier, and also have to look a little bit regarding timekeeping. With all this big amount of data, and some people are calling that big data for that reason, we need some mechanisms to process this data, and artificial intelligence would be the science thinking about it, and the methods of how to do that would then be in the subdivision called machine learning, where you basically, first of all, measure or access all the already available data. I think, again, that's why I like this KPN presentation. Abstraction, yeah, is the key for all these architectures, and I agree 100%, and it is the same thing here. So extracting the correct or relevant data out of this mass of data available is, I think, the first very important step, yeah, because otherwise you would not be able to process this. So analytics is a very important topic, and there are various methods, yeah, how to do that, and I think that's exactly what the scientific community is working on right now, how to extract the best data. Might be then different models be used for different problems, and then using this data for some action in the network, yeah, so feeding that into the orchestration and control system, which would then again change parameters in the network accordingly, and feeding this again back into the measurement stream. So basically achieving a closed loop. That's basically the idea. Yeah? And like I said, the challenge is really to extract the relevant data and to process it then in the right way, if you will. Yeah. And that's, I think, the challenge. That's what these people are doing. And two use cases here would be network optimization. As we know, typically, currently, people are running networks at a certain capacity level, I don't know, 70, 80% of the available capacity. And if this threshold is achieved, then they would start to extend the network. If I would know more about the network, like if I would understand the traffic patterns, for instance, yeah, then I can maybe use some spare capacity at the times where typically the link is underutilized. Yeah. If I, from a physical perspective, understand the channel performance, the optical channel performance, yeah, that can also optimize capacity with different modulation schemes, yeah. So there are a lot of options available, and this would de facto then increase the overall capacity. And of course, another, I think, pretty straightforward thing is predictive maintenance. Yeah, if I've got physical degradations like aging. Yeah, I've got some equipment issues like laser current is increasing. If I detect those things and if I know, yeah, what that means, then again I can recommend replacing of this equipment in advance, yeah, and just decrease the times where the network is not running. Of course, there will still be some failure modes like construction where fiber is breaking. Yeah, this is something you. Yeah, maybe. Yeah, if you would know what the construction guys are doing, yeah, you could also even predict that one. Yeah, but you know what I want to say. Yeah, so you can just increase the availability of the network. Yeah. Good. And with that, I would say so. If we are at that stage, I think maybe we then can all relax, sit at the beach, have a beer, and the network will be optimized by itself. Yeah. And with that, with that outlook, I would say I would like to close my presentation. Yeah, just a minute. Yeah, thank you.